polynomials. And so if you just want to follow along on your sheet with me, the first thing we're going to do is we're going to look at all the different graphs of the first 6 polynomials. So first of all, constant function, that's just a number. Remember, that would be like y equals 2. Y equals -1. That's what a constant function is. A linear function, degree 1. Okay, this might be like y equals x plus 2. Y equals x plus 3. We looked at that. This was actually in slope-intercept form, remember? Quadratic functions. Those are what we briefly looked at before Christmas break. We looked at factoring those. Okay, we're going to look at those a lot more. Okay, cubic functions of degree 3. That's an example of what it looks like. That's not the only thing it can look like. Okay, a cubic function can also look like this. It can also look like this, depending on how many roots that you have. Okay, quartic function is a degree 4. That's going to look like a W or an M, depending on what you have. It can also look different as well, depending on the roots. And then a quintic function, a degree 5, if you look at that. Okay, it could also, do one more, there we go. Could look like that. Okay, so far so good? So first of all, let's go ahead and look at this. The domain of any polynomial is all real numbers. So that's the case. It's always all real numbers. Okay, the end behavior. That's just basically the behavior of the graph of f of x as x approaches positive or negative infinity. All you're doing there is saying what the graph does at the end. Does it go to positive infinity? Does it go to negative infinity? And it's always determined by the degree and the leading coefficient. So let's go ahead and look at this next one. This is actually taken it from your book. Okay, you also have it to look at. Basically, it says, if the degree is even and the leading coefficient is positive, your end behavior is going to go to positive infinity. So let's review that again. If your degree is even, so that means like a degree 2 or a degree 4, and the leading coefficient is positive, your end behavior will go to both positive infinity, so it's going to go up.
Is 0 even?
Okay. Well, no, it's neither even nor odd. Okay. Now, if your degree is even and your leading coefficient is negative, the end behavior is negative infinity. Okay. So, example of this. Notice y equals x squared, y equals negative x to the 4th. Now, if your degree is odd and your leading coefficient is positive, the end behavior here is going to be negative infinity. The end behavior here is going to be positive infinity. If the degree is odd and the leading coefficient is negative, the end behavior here is positive infinity. End behavior here is negative infinity. So, if you want to remember those, that's great. Could save you some time. Otherwise, you can just graph it and look at the graph and tell me what, in fact, the end behavior is. Okay? So let's go ahead and look at this. It says zeros of even and odd degree functions. Odd degree functions will always have an odd number of zeros. Even degree functions will always have an even number of real zeros or no real zeros at all. Okay. So even degree polynomial could have 0 zeros. Or it could have an even number of zeros. By zeros, remember that's these right here. We've looked at those before. And an odd degree polynomial. This is actually a cubic function. Has 3 zeros. Okay, this is a cubic function with just 1 zero. Okay, so odd degree is always going to have an odd number of zeros. Even is always going to have an even or none. Okay, so this is what your homework's going to be like. You're going to describe the end behavior for each graph, determine whether it represents an odd degree or an even degree, and then state the number of real zeros. Pretty straightforward. So first of all, describe the end behavior. So this is going to be the left. This is going to be the right. So you're going to have two answers, L and R. So as you look at the graph right here on the left side, does the end behavior indicate Positive infinity or negative infinity? Negative infinity. Now remember negative infinity because it goes down. Okay. What about from the right? What's that going to be? Also negative infinity because it's going down. So those are the first two answers. Questions on those two? All right, let's look at the next one. Determine whether it represents an odd degree or an even degree polynomial. So this is what you're looking at now. 1, 2. What's it got to be? Even. Okay. Step 3, state the number of real zeros. How many dots did I put? There you go. Those are your 3 answers you need. So let's look at the next one. L, R, left and right. From the left, what is the end behavior? Positive infinity, it's going up. What about from the right? Negative infinity, it's going down. Okay, next step. 1, 2, 3, 4, 5. What is this? Odd. And my next answer is 5. So far, so good? Okay, so here's your assignment. I need you to just turn in your book real quick to page 326 and 327, just so that we kind of know what we're doing. Kind of getting back into the swing of it. Okay, so first of all, the 5 through 7 is not a typo. Okay, yes, I want you to go to the, I think it's the check for understanding section. And I want you to do 5 through 7. That is a repeat from what we did before Christmas break. All you need to do on 5 through 7 is you need to plug in 5 and negative 4 for the first 2 equations. So you just plug in 5. So negative 2 times 5 cubed plus 3 times 5 minus 12 and get an answer. Okay? And then you're also going to plug in negative 4 in the same one. So number 5 is going to have 2 answers. What 5 is and what negative 4 is. Same with number 6. Number 7 is just going to have 1 answer. You're going to take y cubed and plug it into the c function. Okay, next step, 35 through 40. Okay, 35 through 40 gives you a visual. So all you have to do is exactly like what we did in class. And then last but not least, 47 through 50. Okay, use the degree. So on 47 through 50, there's 2 ways to do this. One, you could just look at the equations and see if you can figure out which one it's going to be matched up with based on what we looked at in class. Or 2, you can use your computers and graph those and see which one they match up with. But it's your choice as to what you want to do. Okay.
How do we see it? What?
Because remember what that one slide we did? Okay. If it's an even degree, leading coefficient is positive or negative, this is what the end behavior looks like. So this will be due tomorrow. It shouldn't take you that long. You should probably be able to get that done, hopefully with the remaining class time.